Hey, Josh Sparrow here from Hartfiel Automation. I am the Vision Sensors and Safety Specialist here, and today we will be running through the SICK Inspector cameras. All right, I have now connected my camera up through the Ethernet programming interface, just with an RJ45 cable, and I have pulled up my Google Chrome here. Now, all we have to do to connect up to the camera is type in the IP address. There is no need for downloading any software or anything to program these cameras. You can see what I have mine set to is 192.168.0.1. And when we start up, we're going to get prompted with this empty job template here. Now, you can see there's a couple of other templates here if you're doing something very specific. Most of the time, we're starting with this empty job just so that we can add the tools that we need. Now, I'm going to just name this test job and hit create, and you can now see we've got this test job up here. Now, over on the left-hand side, this is where we're going to add all of our different tools that we've got within our camera. This is going to be kind of the macro level stuff. So acquisition, we've got some pre-processing, our actual tools, results, and how do we communicate. We're going to start with the acquisition here, and then we'll go through some of the others in a little bit once we set up the camera. In the middle here, you can see we've got our live image. Now, the first image that we've taken is a little bit washed out here. So what we're going to do is actually come over to the settings tab over on the right-hand side. Now, we've got our tools on the left, our settings on the right, and our image right in the middle. So everything should be right at your fingertips here. We can see, because we've got that nice washed out middle there, that my internal lighting is set up. And I've got some external lights set up just so we get a nice clear image here. So what I'm going to do is just come in and disable that lighting. Now you can see we took a new image. We also have these different LEDs. So if I wanted to come in and have a reduced amount of LEDs, we're able to do that as well. Again, I'm just going to turn it off for right now. Now our image here is pretty dark. So I'm actually going to come up here. If you are new to cameras, I often recommend running this auto setup. The auto setup does a great job of getting close, and then you can kind of adjust from there. You can see you can use a specific region if you want the lighting to be specific to that area, and then this will go through the exposure and contrast. For right now, we're going to kind of do this manually. So you can see if we go all the way down with our exposure time, we get black. If we go all the way up with our exposure time, we get white. Sometimes, if you don't have a lot of light, you might not need to be up in this 200,000 microsecond range. For right now, I know we are probably pretty good around this 400. So we're going to leave that here. With our contrast, you can kind of see what the change does as well. So we kind of wash out the contrast when we go lower than 1. Then if we were to go higher than 1 here, we do get a little bit sharper here. So very useful when we are looking for very defined edges or need to see that. For our applications, we're going to just stick at 1. And then same with brightness. If we need to enhance that image to make it brighter, it does wash it out a little bit, but does a good job when we maybe don't have enough lighting. Lastly here I'm going to show is the downsampling. So if we need to make this faster, you can see that right now we're about 12 millisecond response time up on the top bar here. If I downsample this to maybe say 9 times, this time does actually go down, so saves you on some speed. But you can see we're starting to lose a little bit of definition on these circles here. So for right now, we'll leave this at 1. A lot of the things here are more about the transformation. So do I want to bring this in to maybe focus in on an area, speed up the camera a little bit? Do I want to rotate this around? We do have some image corrections, which we'll show here in a minute. And then how do we want to trigger the camera? Do I want to trigger via that photo eye or a sensor tied to us? Or do we want to have this command channel trigger via Ethernet IP or something like that? And then lastly here, we can record images through here. Um, we will show a better way to do this, but if you wanted to record images, especially when you're setting up a camera and need to collect a lot of data, we can do that right through here. So before we run into the other tools, I'm actually going to come into this system tab here. We're going to set up the camera a little bit more. So we've got our IO configuration to start. You can see that we have a handful of IO here. Our IO1 is always going to be our image trigger. And then other ones, we have some options here. So our IO2, you can see we've got an encoder input. We can use it to update our reference image or job selection. The other guys here, we are able to do that job selection to build out a tree. I can trigger that external light if we wanted to, or update that reference image. So you're able to kind of set up your IO depending on what you need. The next tool that we have here is the fieldbus tool. Now, I already have this set up as Ethernet IP, but you can see we can turn this off or have Profinet or Ethernet IP here. We can do DHCP if we need to. And then one thing to note is that we can have a separate IP address for the Ethernet IP than we do as the programming interface. Really useful if you're connecting to a PLC but still want to program it without interrupting that traffic. Some of the other tools here that we can add is a command channel. So again, if we wanted to control the camera through an external source, we can come into here and say, I want to interface via fieldbus. Now we could do that with the fieldbus, we could do it with serial, we could do that by setting up some of these TCP or UDP tools as well. We'll just leave it as fieldbus for right now. And then coming into here, we do have a job selection IO tree. Now we only set up that one IO here, and we really only have one job. So as long as that IO2 is low, we are going to be on this test job. This does make it easy to switch between a limited number of jobs, but most people these days are actually triggering this job selection via the field bus so that we have basically unlimited amount of jobs that we can switch to. We're not limited to however many IO we can build with this IO tree. So I am going to delete this guy and then move down to our calibration. So we've got a calibration target. And if I just hit live here, you can see as I move this around, I'm going to kind of get this centered in here and hit the stop button. Then our settings, when I click on it, show up over on the right-hand side. Now, I have a 3-dot target, and then I know that this is 16 millimeters because we have set that up beforehand. To find these targets, you can click this read more and it'll bring you to the support portal page. Otherwise, I've found just going to the product page here and going to downloads. And this is in software and coming down here to the calibration target. This just downloads a zip file with a handful of different calibration targets. And then all you need to do is measure what those X and Y's are as they map or as it prints out. So I'm going to estimate this position. You can see we get the amount of error that we've got, and then we'll be able to go back and hit that acquisition settings. This really allows you to kind of lay your image a little bit flatter and get the actual millimeters out of here. Other stuff on this system setup page, date and time. I haven't done anything, so it clearly is not 1970, but we'd be able to set this up or set it up on a time zone server of some sort. We can do license. We've got the intelligent inspection license, but if you wanted to add AI tools to a quality inspection camera or you needed to manage your license, you can do that here. And finally, we are able to do different permissions. I'm not logged into the camera right now, and I have it wide open. So you can see we can configure the application as an operator and export it as an operator if we wanted to lock that down so that only certain people could have access to changing the jobs or modifying the program. We could do that right here. So we're going to come back here and go to our acquisition settings just by clicking on that, and come down here and do our full calibration. So as soon as we do that, you can see that now my boxes are nice and straight. This is getting rid of a lot of the lens distortion that we run into, and giving us again that actual millimeter measurements inside of here. So now that we're set up, we can start running through some of the tools that are on here. So a couple of tools that are nice is just some pre-processing. So I'll show this morphology operation. So we've got a couple of different options here. Now, if you're not sure what erode and dilate and open and close mean, we can actually come into here and click this read more button right here. SICK has done a really good job where they've started to pull out some of the operating instructions and pull it into the software itself. So we can actually come into here and go, okay, what does erode mean? Erode. This setting will increase the size of dark areas and decrease the size of bright areas. Okay, now you're able to very quickly know what these are. We do also have a noise reduction tool. So if you are running into some noise that you want to get rid of, say our brightness is up pretty high, we are able to do that here. Again, for this application, we're going to just kind of run by. So now we get into our analysis. This is where the meat and the potatoes of the vision software are. So we've got a couple of different tools kind of grouped together here. We've got our locate tool, so blob locators, object locators, and we'll show that in a minute. We've got some of the shape tools. So am I looking at circles? Do I want to find lines? Anything like that. Once we have our shapes found, we're able to get angles between them, distance between them. And then once we go down to our count and find, we start getting into some of the AI tools that are available. And we'll show some of those here in a minute. But just note that there are D-Studio versions of some of the tools, which basically means that we are going to load a neural network in here rather than training on the camera. Now, I won't show the D-Studio here. If you do have questions, feel free to reach out. We might do a video on that a little bit later if we get more interest. I'll delete that guy. We are able to do classification, so more of your standard AI tools look at specific regions. AI anomaly detection has been very popular for label verification or looking at products that have small scratches or flashing or anything like that. We've got a bead tool for welding beads or glue beads, your standard pixel counters. Character recognition has been very popular lately, and then your 1D and 2D codes. And then we do have an area here for other. So we can actually load in beta apps or other apps that people have written for these cameras and load them on here without much issue. Finally, we do have our results here. So being able to do different expressions, logical expressions, math expressions, anything like that. And then we do have our result strings, being able to send maybe a CSV out to a computer or send a string over TCP/IP. And then our communications, sending that string. Do I want to set up my communication with Ethernet IP or just set up digital outputs? And then the kind of more robust way of this image collection. And we will show a little bit of that as we dive into an application. So now that we've got our camera set up, I'm going to come in and trigger the camera just on a small little photo eye that we have here. So we can see we've got a H18 sensor, and we're going to come in and just do a couple of things to this. We're going to start by adding a reference image. We always want to work off of a known good image. So come into here, and our reference image, you can see that I'm not live now. We can download that image if we want to. but a lot of times we start off of this known good. So I'm going to come into here and show the object locator. Object locator isn't necessarily always needed, but it is good, especially if your um, product moves very slightly, or there's some rotation, or you just want to make sure that you're locating always correctly. So you can see here that I've just got a bounding box for the tool, and then I can rotate around the z-axis. I can come in and make this as big or as small as I want. I can even change this if I wanted to a ellipse or a polygon and really highlight this as neatly as I want to. Now for this application, I don't need to get very specific, so I'm going to just kind of do a general overview here of the sensor and get pretty close. Now on this edge tool, we want to come in and find where the edge strength makes sense. So if we bring this down, you're going to see there's going to be slight changes on what I am outlining. So these smaller little defects or cracks or scratches are going to start getting caught, versus if I move this up, we might only catch the outline. You can see, I might only catch this black part on the back, which might be enough for the application. So here we're catching kind of the circles for the mounting holes, and then that black back, which actually works pretty well. Maybe I want to kind of take this nose away. I can either move my bounding box, or I can come into here and do a subtract region. So maybe I want to get just this and make sure I'm filtering out specific areas. This is very useful if you're doing, say, bottles with different labels on them, or parts where something can change a lot. We don't want to look at those specific areas, but we want to look around them so we can mask out different areas. Now, inside of here, you can see we can set up different background clutters. We've got a pretty noisy background here, so I'll leave that as high. I'm going to allow this to rotate 180 degrees. And then if there is some height variations, we can get into the scaling. And then again, that downsampling. So we're able to downsample a little bit more or less, depending on what kind of speed that you need. Lastly, on the top here is just a search region. If we wanted to look in a specific area for this object on our object locator, we could do that. Again, helps with speed. It helps if there's only certain areas where this object is going to show up. And then as we go down here, we are going to see the results over on the right-hand side. So as I come into here and go back to my live image, if I move this part and rotate it, we might see that match score change a little bit, or be, pretty low here. So I can come down and say where I want that tolerance of my rotation to be. I can also come in and say where the pass and fail is. If I want to make sure that this is always right on, I can say, you know what, I'm going to be at, say, 30 degrees to 60 degrees. And then if it's outside of that, if I rotate a little bit more, we might still find it, but we're outside of the angle that we've set up. You can see we've turned red here. We can pass and fail on that. Now, I'm just going to set this on max because I want to pass and fail on some other tools instead. But we are able to set that up for just about any of the tools here. This is really useful once we start getting into our I/O for passing and failing products coming through. Now, what I want to do here is actually add some tools onto this sensor here. So we can see I've got the two add tools here now. So I can add tools. This bottom one will bring it underneath the analysis. So if I wanted to do, say, a fixed point or something like that, I could come into here, and this fixed point would always be right here. Now, I am not indented underneath the object locator. So if I come in and add a tool underneath the object locator, say a line fitter, I can actually come in and see now on the left-hand side, we are indented on that object locator. So I can come in and now find my line. As I move this now, say I move my photo eye up just slightly, we can see my object locator did not find that, probably because our lighting is a little bit funny. So we'll just turn this down for right now. Um, but now our line fitter has moved alongside the photo eye. Very easy to set up so that as your product moves just slightly, you are able to always get a nice view where you want. So if I wanted to change these, I can also come in and move this line fitter up to analysis, and you can see that it now does not move. It's going to be based on where you set it up in the reference image then. Versus if I come back up to our object locator, because we had this in our reference image set up on the back of the sensor, it's going to follow along with that object locator. Cool. So I'm going to set up just a very quick another fixed point, and I'm going to do a line between the fixed point and do a fixed point and a fixed point. Now, these are just out in space here. These will always be fixed. A nice way to have your fixturing there, or have a known point that's lined up with the coordinates of the camera. I can then come in here and maybe I'll add another line tool on our photo eye. Looking at the front of this photo eye here, and you can see as I narrow this in, we're getting a couple of different points here because I've got really two edges that it's fighting with. So my settings over here will let us really come in. Our bottom one here was nice because we had a black line, a lot of contrast. Now that's not always the case when you're working on a camera. So we can actually come into here and go, I'm going to go from bright to dark. And I want to come into the advanced and really pick that first line rather than the strongest line. I can bring this in here. And now you can see we are picking up that little scratch in the background, but most of them are right here. Now that scratch in the background, again, just like the object locator, maybe we can come in and find a spot that it really makes sense on the camera to get this set up. We can also come in and look at our outlier margins. So I want to know, within 3 millimeters or even 1 millimeter where the lines are. We can increase the number of probes on here. So if I wanted to get much more accurate, or I really just want a general, we're able to do that. And then we do have kind of this edge fuzziness. So you can see, even though now we're picking up a couple of those points, most of them are right along that edge. So we're getting a nice edge there. We can also narrow this down because we know where the photo eye is always going to be. And then again, just like the object locator, these lines do have some different results. So if we wanted to do, say, a look for flashing, or maybe on a board, there's an indentation on the board, we would actually see this average error go up, or maybe we'd see this edge detection go down. And so we could pass or fail off of that right here. So now that I've got a couple of lines and a fixed line here, I'm going to come into here and do a measurement. And I want to do a measurement between the sensor. I want to know how wide that sensor is. So we can come into here and, man, these are kind of hard. I'm not sure which one is line and line one. So before I do that, I'm actually going to come here and right click on the line fitter and hit rename and say backline. And I'm going to come into here and rename this to be nose line. And now I can come into here and you can see that I've got backline and nose line. And I'm actually going to say, okay, I'm going to go to the line, and I'm going to go to the line. And you can see I've got these set up on point to point, and we're kind of crooked. So this is really going from the middle of that line to the middle of this line. But we've got our settings here, so I'm going to actually set this up to do a right angle. And now we're able to see that we get a nice right angle between the two of those. Now here, instead of a slider, we're actually looking for a distance. And because we had this set up in the system on our calibration, we actually have 31.27 millimeters. If you didn't have that calibration, you would see this in pixels instead. So H18 should be pretty close to each other. So what I'm going to do is I'm going to set this up for 31, and maybe I'll set this up for a tolerance of 3 millimeters. And now we can see we've turned green. We're good to go. The other thing that I'm actually going to do here is I'm going to take my angle measurement, and I want to measure from the back of that line to our fixed line. So pretty neat to be able to come in. We actually get a specific point on that intersection. So being able to do different pivoting applications or anything like that, right off of here, I can change between clockwise and counterclockwise. And then again, just like this, we can set something up that's looking for a specific angle here. Now, I'm just going to set this up 90 degrees with the tolerance of 90 because I just really want a more FYI of what this is rather than passing or failing on this. And I'll show you how to give this information out to a PLC as well. The last thing that I'm going to add here is I'm going to add a OCR tool. Now, this OCR pre-trained tool is using an AI to work on this. And we're going to come down here and read the SICK name right here. So you can see we didn't really have to do a whole lot to get that SICK name. We can also make this bigger and see that we are reading all of the different text on here if we wanted to. And that again will follow along with the sensor, so we should be able to read this at all times. We can make this a little bit more robust for those harder to see applications. We can also get some of that downsampling again. Maybe we might have text upside down, or we might want to only use capital letters or special characters, anything like that. And then we can sort this, so line by line, top to bottom, left to right, can be done inside of here. Now, the one thing I will say about the OCR, it is a pretty slow process. In this results, you will see throughout all of our different results here that it gives you the execution time for that tool. So just keep that in mind. So now that we've got this kind of set up, this starts to get a little bit messy on my screen here. So we're going to come back to here and start turning off some of the graphics here. So as I hover over a tool, I've got the object locator here and I've got this eyeball. Now if I click this eyeball, it gets a strike through it and you'll see that that blue outline of the object locator disappears. If I want to keep that on all the time, we're able to do a box around it, which means that it's always going to be available. So what I'm going to do is I'm actually going to turn off some of these guys. I'm going to turn off our fixed points and our fixed line. I want to keep my distance here. So I want this to be always present. I want to keep my angle always present. And then we can either add the OCR or not. Let's just turn this off for now because we can get that out in a couple of different ways. So now that we've got that, we're going to add a expression here that looks at some of our tools. So now I can come in here and kind of see what the different um, selections that we can do inside of here are. And then we will be able to really do a lot right inside of the camera without ever getting the PLC involved. So if I wanted to come into here and say my angle needs to be less than 71, and we can see that it says it's 64, this would give us a true signal out. But I want to also look at this and say my distance, let's do maybe an ampersand distance that we have set up is greater than 30. Now you can see this is yelling at me. This expression could not be parsed. So, ampersand, different people have different syntaxes here. So what I can do is, again, click on this, read more. Inside of here, they actually have a lot of different examples to be able to get different expressions written. And then if we go all the way to the bottom here, they actually have what all of the operators should be. So we come in and see, oh, and it shouldn't be an ampersand, it should be the word and. So now I can come into here and say, and this should be happier with us. So now because our distance here is less than 30, our angle is less than 71, we get this true signal. So we can set this to an output, or we can set this to do, again, different things inside of here. I'm going to also build a result string here. Now our result string, maybe I want to have what my job name is so that the robot might know what my job name is, comma. Maybe I want to know what the center point on that back line is with a comma. And then maybe I want to do that text string right here. So now out of here, we get the job name, test job. We get the center point of this back plane of the sensor and the XY, and then we get what sensor it is. So now we're able to start getting a lot more information out of here right from the overall string here. And then we can come into our communication down at the bottom. So this image collection is very powerful. We are able to either store it on the FTP server if you are connected to a network or a PC or anything, or throw an SD card in there and be able to go right to that SD card. Now, what's kind of nice about this, we can add the file name, but if we wanted to add, say, a date and time, we could add that. If we wanted to add, what tool it is that failed, or different text results or anything like that, we can add that to the file name here. And then we can come in and say, when do we want this to save? So we could come in and say this expression, as long as those two are true, I want to have this save an image. A lot of times what you'll want to do is put a couple of different tools inside of an expression and say, as long as none of these fail, I want to not do this. So if this is false, I want to save the condition. So we could do that coming into here and saying if this equals false, we can see now that this is false. Now, if either of these were not false, um, or not true, excuse me, this would turn true, which would then mean that we're out of the tolerance that we set up for the sensor, and we're going to collect that image. So very powerful to be able to see what's going on right in here. We can also set up digital outputs. So most of our digital outputs were set up for uh, the output out of the camera in that system tab. So maybe I want to come into here and have a results ready bit. So I know that as soon as the camera takes an image and the results ready bit goes high, we can say, okay, we are good to move on to the next part. And then maybe we can have this any passed or all passed or any of them fail, or we can look at very specific applications here or tools here. So for right now, we can do this any fail. If any of them fail, I want an output. And then maybe I want to have a all passed, just so I know that everything's going well in the camera. And then again, we can do that through our Ethernet interface as well. So we get a lot more information here. We can set up, the job ID here. Maybe I just want to pass in the distance value here, and we can select another one to do, say, the object locator. We could even give the X, Y, and the rotation around. We could get any error codes. We could get, what that um, here angle is. Or if we actually came in and got some characters, we could again grab that output string that we set up here, and maybe we get another character that has just the pre-trained or the OCR text in it, although I suppose this has it in it as well. Now, once we set this up, we can actually download the UDT for the PLC, pass that right in. So it makes it very easy to come in here and add different data types and everything, and then map it in the PLC. So now that we've got this standard job set up, I want to show a little bit of the tools for AI, because this is something that's really starting to become pretty powerful. So I'm going to hit the plus button up here and create another empty job, and I'm going to say AI job and create. So now you can see, again, our image. We have to come in and set this up because images are per job. So I set that up at 400. We've got to make sure we turn off the lights as well. And then everything else seems to be pretty good here, so we'll leave that the same. Now, I'm going to come in and add a handful of H18 sensors here, and then take an image, and we can come in, and one that we've been seeing a lot of people use is this AI object detection. So this AI object detection, what we can do is actually come in here, and we've got this radius set up. So I think we're going to need a little bit bigger radius. So let's do maybe a 300. And I'm going to just come around each of these H18s and train the AI on what these look like so that it tells us how many of these it sees, tells us where they are. I'm going to take another image and really refine this a little bit more. And then I'm going to introduce here a second sensor and take another image. And you can see how this actually originally thinks that it might be an H18. If we come down here, there's no other classes, so it doesn't really have anything else to compare this to. So what we're going to do is we're going to come in and say, well, these are H18s, but this is actually a G6. So let's call this G6. Let's call this H18. And now, just like the H18, this guy's a little bit smaller. That might not be enough. Let's go up to 250 and grab this guy. Now you can see it's locating this guy correctly. Now, if we come down to here, we're able to see what the class name is, what the center of gravity is. So we're doing this a lot for robotic applications where we are looking for, say, holes to be able to put in different bits or threads or anything like that. We're doing this a lot for kitting, being able to count what kit this is in or what object is in there. We can also add tools onto here. So being able to add character recognition tools or some of the measurement tools that we showed in the last step is pretty powerful. Now, another thing that we can do here is inside of our classify. This is more of your traditional AI in cameras that people typically think of. So if we came into here and just created an area and took a new image, we could again have an H18 class. So maybe we'll name this H18 class. I'm going to add an image. I'm going to come in, add an image, add a couple of these guys here around. Just so we get a little bit on here. And then I'm going to, again, throw that G6 in and have a G6 class. G6. I'm going to add the active image and do the same. Now, in your process, you would actually throw this in to your process itself and find the different deviations inside of the sensors, in this case, or whatever your part looks like while it's actually on a line or a conveyor or whatever, to be able to get kind of the deviation. This is one that we use the D Studio a lot if we get into a lot of different classes or a lot of very close together, say, power supplies or something. But we're going to do this just quick on the camera itself. And we can see now that we get this G6 just after a couple of images of the H18. We get kind of the results of how confident am I that the class is a G6. What's the difference between what I think it might be and the next biggest thing? If I put this H18 back in here, you can see I put it down towards the bottom of this box. So it's really not as confident because I didn't teach it quite as much. That's pretty confident it's an H18, but it could be a G6. If I move this up to more where I taught it, it should get more confident. It's probably also a different H18 that I grabbed. And you can see when this starts happening, we need to start adding more classes here. So add another active image. Let's grab another guy here. You can see now that I moved it slightly, it's again an H18. We might need to come into here and just grab a couple more images and redo our training. Again, the training on the camera is meant to be kind of your simple applications, coming in and really making this more robust. You can see adding a couple more images. Let's bring this back down. Has really helped with that quite a bit. We can see that class differentiation just by adding 3 more images on here. So on camera, we can actually do up to 100 images per AI tool. You can also see that we have multiple AI tools for our or per job here. So really the limit is how fast your camera needs to go. With these 2 AI tools, we are only at 55 milliseconds. So the 800 series cameras really are made for AI applications. They have an AI chip built in, really useful for some of those typically harder applications that people run into. Now, collecting all these images you can do through that image collection. Otherwise, if you have a camera set up, you can also see all of the images that have been loaded onto the camera right through this File Explorer. So hit our menu here, File Explorer, and you can see we don't have an SD card, but we've got a couple of different applications here, right in here. The Nova is the platform. And then we've got our different anomaly detection and classification and object detection images. So we can add from here or add into here as well, just by dragging and dropping. Once we are done here, and say you've got your application set up the way that you want it, the next part is actually implementing it out on the line. And a lot of times we want to build an HMI out. That's where this dashboard tab over on the left-hand side comes in. We actually can very easily build out a dashboard. You can see that right now we just have an overall pass and then our 2D view here. So if I wanted to come in and maybe make this a little bit smaller, maybe I wanted to add a result and I want to take this classification and tell me what the class index is, or maybe the class name. And I want to have what is here. H18 is here. If I wanted to come in and say we've got our 2 different jobs that we've set up, we can actually come in and have a job selection toggle. So now I can have this job selection toggle right here. So an operator with a touchscreen or something can actually come in and change between our couple of different jobs here. You can see the one thing that comes in, because we don't have a AI classification tool 0 here, we don't have that result, but we can set up, your OCR coming on here or anything like that. The last thing that I wanted to show is actually the application manager or app manager that SICK has. So these tools are all built up of different apps inside of here. The main app that SICK has is called Nova. And this is the programming interface that we've been going through, is that Nova interface. You will see on here that each of these different tools that we've been using is just a different app that lives on this device. So we've got anything from our serial app to our OCR app to that main Nova app on here. What this means is that we are able to add on different apps if we have something that we either want to write ourselves or that SICK has written. This also gives us a very good way to update the camera and the firmware for free. You can go onto the SICK website and just search for App Manager and download this. This will connect up no matter what the IP address is, so being able to find cameras on your network that you're not sure of. If you want to factory reset devices or anything like that, you can do that through here. And then you can see that we could actually come in and update the camera. update the firmware right through here. That means that with the inspector, there's no charge for new software or anything like that. You grab the camera and you've got the updates for the life of the camera. Really useful as new tools come out. SICK is doing a very good job of updating these cameras quite often with new tools, new AI tools, new measurement tools, and even just adding more functionality, like adding more of the documentation into the cameras, adding more of the documentations into those read mores. So very nice to be able to keep your camera all set up here. We can even do some backups and stuff. You can back the camera up through this menu, and you can export and import the configuration. But some people like to have a kind of nice database right here. So that is the overview of a SICK inspector camera. We will be having a good amount of videos coming out that show connecting up to PLCs and show different applications. But if you have any questions or would like to have a live demo, please reach out to your nearest Hartfiel Automation account manager, and we'd be happy to stop by, throw a camera out in the process, run through tools with you, whatever makes sense. I look forward to talking to you soon.